Hey there, I'm Ben. This is the project we're going to be talking about here today. So I bought this thing this summer. It's a Milltronics, like a 1998 Milltronics Partner 00, Model 00. It has a Centurion 1 CNC controller on it, but it can also be used as a manual milling machine. So I got it this summer, and when I bought it, it has like a 486 computer in it. It would not boot up all the way into the software, like to Windows or whatever. Or it's not Windows, but it's the underlying operating system. So what the deal is after a bunch of troubleshooting and talking with smart people, I determined that it was an issue with the BIOS or CMOS battery. So the CMOS battery on new computers is like a little watch battery, and it's easy to replace. On these, it's actually soldered onto the hard drive or to the motherboard. And the problem with that is it sounds like basically, unless you're really a pro at soldering, you'll mess it up, and then the hard drive or the motherboard will be shot. And so sounds like it's like a 10% success rate for just DIY home do-it-yourself or just doing it. So I don't really want to do that. And I mean, I went to school for electronics and I don't have a problem with it, but there's a couple other things that I'm looking at. If I did that, then I would have a 1998 or 1999 model, state-of-the-art 1998, so that's 20 years old now. It's 2018 right now. A 20-year-old state-of-the-art machine that would be functional. It would be able to get some stuff done, but it wouldn't be able to do a lot of the stuff that we expect out of modern CNC machines. The other thing is the costs for keeping that system up and running. Let's just say it's expensive. That being said, I have decided to do a Centroid retrofit on it, so I'm going to use an AllInOneDC control board. So that board should allow me to do pretty much any 3D milling or whatever that I want to do, and be kind of great. So all that being said, here's the thing I'm struggling, or not struggling with, I guess I've made my decision now, but I was having an issue trying to figure out how I wanted to power the motors. So these drive motors on 3 axes, it says the max voltage is 140 volts DC. So let me go show you that here so you can. So let's see. If you go, let's see. I will turn this the proper way, if possible, and show you that data plate. Let's see, where is it? So if you look up there, it's 140 volts DC max, right? And so the problem is that this machine, it rectifies 110 volts, it transforms the 3-phase down to 2-phase, then down to 110 volts DC, which is fine, but then it rectifies it to 110 volts AC, and then it rectifies it to DC at 160. So here's where that is shown in the manual. So 3-phase in, that's used mainly just for the spindle. Then it goes to single phase, or it picks up 2 legs of that into a transformer. That gets transformed to 110 volt AC. Goes through a relay, basically like a proxy. Anyways, it's like a switch. And then it comes over here and you see 160 volt DC 2 drives. If you remember, those motors I have only allow 140 volts. So what happens is it doesn't actually go to the motor, it goes to the drive, which is a Gentech, it's this GA370, mine's a -3. And if we look at that, it allows for 65 volts DC to 170 volts DC input. That's fine, we're at 160, great, right in the middle. But the output from this is 100 volts DC, which matches the motors. That's fine. However, I'm not going to be using these drive boards with the Centroid setup. So the Centroid setup, it has that built in. So I'm going to be using this, and I'll take in, here's the 3 axes, 1, 2, 3. So I'll take in 160 volts here, and that 160 volts is going to turn around and head right back out to the motors. Well, I don't want that because I don't want to blow those motors out. They're expensive, like $1,000 a piece. So what I'm going to do is I'm going to actually get a separate transformer that'll go after the 110 volt the 240 to 110 volt transformer. That'll actually transform the 110 volts down to, it's called a step down transformer. It'll step it down to 83 volts AC. Then when we rectify that, it's whatever the AC incoming voltage is times 1.414, and that equals, give or take, about 100, I think it'll be 130 some volts, which is anyways 125, 130, that's fine. It's less than the 140 that my motors allow. So that'll be perfect. It's just unfortunate that it costs another $400, but so that's what I'm going to be working on here today is I'm going to wire up the Centroid board, this control board, to my computer, get those talking just by themselves without anything else hooked up. And then I'm going to start taking the motors off of the machine itself back over there and get the, they have new encoders and new encoder rings. It sounds like something from a Cheerio or a, what was it? Not Cheez-Its, Cheerios. Anyways, Cracker Jack. It sounds like a Cracker Jack toy, but anyways, they're not. They're expensive little super precise rings that measure how many revolutions have happened, and so it allows your brain, your computer, to accurately move the different axes, certain number of thousandths of an inch or whatever. So kind of a cool deal. So that's what I'm going to be working on, and just kind of getting that up and running. And then I need to order up that other transformer, so I should have that hopefully by the time I'm back from Texas in a week or two. Anyways, that's what I'm working on, and come along for the ride. Let me know if you have any questions, concerns. You know, you think I need to shave or something, which I do before church tomorrow. And but anyways, yeah, happy to have you along learning with me. So hopefully it's not too expensive. I don't break anything. Catch you later.